Good morning. It's Mr. Crouch taking a look at dynamics, which of course is the study of F net equals m times a. And this time we're looking at the hanging off a cliff example. In this situation, we've got a book that's sliding across a desk, getting pulled off the cliff by a 1 kilogram mass. This one's M2. So we've got a few masses here. M2 is 1.0 kilograms, and M1 up here is 1.7 kilograms. And we've got some other values we'll put on there, and then we'll find out what the acceleration of the book is. This example, we'll say that the coefficient of friction between the tabletop, it's a horizontal tabletop, and the book is 0.33. So we'll need to calculate that force of friction. The force of friction is stopping the book from moving, so it's in that direction. And in the tug-of-war of forces, the force that's bringing the book to the right and eventually off the desk would be this 1 kilogram times 9.8, of course. So we've got force of friction right here that we have to calculate, and we'll also have to calculate the weight here of the mass, which is pulling it off the table. So the winning force is weight 2. It's pulling its mass down and also pulling the book to the right. And the losing force on the book is the force of friction. Both of the masses are moving. M2 is going down, M1 is also moving. So we have to consider both of them when we go M times A. Had to calculate the losing force, which is the force of friction. And force of friction is just mu times the weight. And in this case, it's the weight of the book, which is 1.7 times 9.8. When you go mu times the weight, you get 5.50 newtons. So we've got 5.50, and that equals mass of both of them, which is the mass of the weight plus the mass of the book times A. And we'll just calculate that one in just a second. And we get 9.8 minus 5.5, which is 4.3, equals 2.7 times A, because it's the mass of both of them, times A. I have to divide the 4.3 by 2.7 because I just want A on the one side. And if I do that, then I get 4.3 divided by 2.7. I get 1.59 meters per second squared, which equals 1.6 meters per second squared. And if you were talking about the book, that would be 1.6 meters per second squared to the right. And if you were talking about M2, the weight, then it would be 1.6 meters per second squared down.